YouTube tutorial on regression and classification accuracy metrics. In this video, we will explore the important evaluation measures used to assess the performance of regression and classification models. Accuracy metrics play a crucial role in understanding how well our machine learning model is performing. Whether you are working on regression problem where the goal is to predict continuous value or classification task where we predict discrete classes, accuracy matrices help us quantify the model's predictive power. In this video, we will examine many performance indicators used frequently in machine learning. The performance and efficiency of our machine learning model are measured using performance metrics. In machine learning, the performance of a model is often evaluated using performance metrics. These metrics help assess the accuracy and effectiveness of classification and regression algorithms. The choice of performance metrics depends on the type of problem being solved and the specific requirements of the project. In this video, we will discuss some commonly used performance metrics for classification and regression problems. So, in regression performance metrics, we use several metrics. One of them is mean squared error. Regression problems involve predicting continuous numerical values, such as house prices. Here are some commonly used performance metrics used for regression algorithms. So, for mean squared error, it is a commonly used metric for evaluating the performance of regression models in machine learning. It measures the average squared difference between the predicted and actual values and is calculated as follows. MSE is equal to 1 by n into sigma of yi minus y bar to the whole square. Here yi is the predicted value, y bar is the actual value, and n is the number of samples in the dataset. Mean squared error value ranges from 0 to infinity, with lower values indicating a better fit. Despite being a popular metric, MSE has the drawback of being highly influenced by the outliers in the dataset. This means that a few extreme value can skew the MSE and lead to inaccurate results. To overcome this issue, other metrics like RMSE and mean absolute error can also be used. RMSE is the square root of the mean squared error and is more interpretable than mean squared error. MAE measures the average absolute difference between the predicted and actual value and is less sensitive to outliers than MSE. We will discuss all of them in the later video. So, sorry. Yeah. Mean absolute error. Mean absolute error is widely used performance metric in regression analysis and machine learning. It measures the average absolute difference between predicted value and actual values, and it can be calculated as follows. Mean absolute error is equal to 1 by n into sum of yi minus y bar, where MAE is more robust to outliers and extreme values in the dataset than mean squared error, because it is equally sensitive to all errors. However, mean absolute error does not take into account the direction. Like we cannot find out that if our model has underpredicted the y value or overpredicted the y value. Here in the formula, yi is the predicted value, y bar is the actual value, and n is the number of samples in the dataset, and the MAE value ranges from 0 to infinity. The lower value indicates better accuracy. MAE does not account for the direction of the errors and can produce misleading results if positive and negative errors cancel each other out. So, to address this issue, other metrics such as MSE and RMSE as MSE and RMSE have been discussed earlier, particularly in dataset with outliers or extreme values. It is important to consider the specific parameters or requirements of the project and use the other evaluation metrics to obtain a more comprehensive understanding of the model's performance. Other matrices like MSE and RMSE can provide a more complete picture of the model's accuracy and effectiveness. Here, root, root mean squared error. Root mean squared error is a widely used performance metric in regression analysis and machine learning. It is a measure of the accuracy of a regression model that calculates the square root of the average of the squared differences between the predicted and actual values. RMSE is a popular evaluation matrix as it provides a comprehensive understanding of the model's accuracy. The formula for RMSE can be followed as below. Like it is a square root of 1 by n into sum of y minus y predicted minus y actual to the whole square. As we can see that 1 by n into sum of yi minus y bar to the whole square is like MSE, and after that its root is calculated, that makes it like RMSE, root mean square error. Compared to mean absolute error, RMSE is more sensitive to large errors because of its square root calculation method. It is also more interpretable than MSE, which has squared units. Despite its advantage, RMSE also has some limitations. It does not account for the direction of the errors. Like it, as in mean absolute error, we cannot find out if our model has under predicted or over predicted for some value. This happens same with RMSE. It is crucial to consider the specific requirements of the project and use the better accuracy metrics accordingly. In conclusion, RMSE is a valuable performance metric for evaluating the accuracy of regression models, particularly when large errors can significantly impact the outcome. Using appropriate evaluation metric for regression model, it is critical to understand their effectiveness. R squared R square is a popular performance matrix used in regression analysis to evaluate the goodness of fit of a model. It also measures the performance of the variance in the dependent variable that can be explained by the independent variable. R square ranges from 0 to 1, with 1 indicating a perfect fit between the model and the data, and higher R square indicates better model performance. In explaining the variance in dependent variable, R square is a widely used metric that helps us to determine the accuracy of a regression model, and it is essential in selecting the best model for the given data set. A formula for R square can be given as R square is equal to 1 minus SS RES by SS total, where RES is the sum of squared residuals. That means the difference between the actual and predicted values of the from the dependent variables, and SS total is the total sum of the squares, the difference between the actual and mean values of the dependent variable. R square value ranges from 0 to 1, with 1 indicating a perfect fit between the model and the data, and 0 indicating that model does not explain any of the variance in the dependent variable. So these are some regression performance metrics, and now we will move into the classification performance metrics. So what is a classification problem? Classification problem involves predicting discrete values such as whether an email is spam or not, an image is of cat or dog. These kind of problems are solved in classification. Here are some commonly used performance metrics for classification algorithms. So first of all, we use accuracy. Accuracy is a commonly used performance metric in machine learning that measures the proportion of the correctly classified samples by total number of samples in the data set. It is a simple and intuitive metric that provides an overall evaluation of the model's performance. The formula to calculate the accuracy in a classification problem is something like number of correctly classified samples by total number of samples. That is how you calculate accuracy. In other words, accuracy is the ratio of correctly predicted samples to the total number of samples in the dataset. For example, if a classification model predicts 90 out of 100 samples correctly, the accuracy can be 90 by 100 or 0.9 or 90%. Accuracy is usually expressed as a percentage and provides a simple and straightforward evaluation of the model's performance in predicting the correct class labels. However, as mentioned earlier, uh, it can be misleading in the imbalanced data set and should be used in conjunction with other evaluation metrics like precision and recall and um, F1 score. So we will discuss other accuracy metrics later. Here it comes precision. Precision is a metric used to measure the quality of a classification model, specifically the fraction of true positive predictions among all the positive predictions made by the model. It can be calculated as follows: precision is equal to true positive upon true positive plus false positive, TP upon TP plus FP, where TP are the number of correct positive predictions made by the model and false positive are the number of incorrect positive predictions made by the model. In other words, we can say that the precision tells us how often the model correctly predicted a positive class when it actually was a positive. It is useful metric in scenarios where we want to avoid false positives, such as in medical diagnosis or fraud detection. Like we want to find out how many people were really like diagnosed with some cancer, or like how many of them were fraud. A high precision value means that the model is making very few false positive predictions, which is desirable in such applications. Another one is recall. Recall is a metric used to measure the completeness of a classification model, specifically the fraction of true positives among all the actual positive instances. It is actually as followed: recall equal to true positive upon true positive plus false negatives. That means TP upon TP plus FN, where true positive are the number of correct positive predictions made by the model, and like false negatives are the number of actual positive instances that model failed to predict them as a positive. In other words, recall tell us how often the model correctly predicted a positive class out of all actual positive instances. It is useful metric in scenarios uh, where we want to avoid false negatives, such as in cancer diagnosis or spam detection. A high recall value means that model is correctly identifying a high proportion of actual positive instances, which is desirable in such applications. Another one is F1 score. As discussed earlier, like F1 score is also a metric that is used in classification problem. It is harmonic mean of precision and recall, and it can be used as the measure of overall performance of the a classification model. It can be calculated by uh, finding out the harmonic mean of the precision and recall, like 2 star precision star recall, 2 into precision into recall by precision plus recall, where precision and recall are calculated using the formulas we provided earlier in the earlier. F1 score is equal to 2 into precision into recall upon precision plus recall, where the F1 score also gives a equal importance to both precision and recall, and it provides a single score that balances the trade-off between the two metrics, that is precision and recall. It is a useful metric in scenarios where we want a balance between precision and recall, such as in sentiment analysis or fraud detection. A high F1 score means that the model is performing well on both precision and recall, which is desirable in some applications. So these were some uh, accuracy matrices that are used in classification models. If you have liked the video and I have helped you conceptually, then please don't forget to subscribe and like the video, and please comment your views. Thank you.